This short course we call Sentinel Communication Setup. So let's start talking about communication. When we look at communication from Sentinel software, you have several choices, starting at the top, Ethernet to the satellite, cell data modem to the satellite, CTM to the satellite. Now let me explain to you what the CTM is. I'm going to stop there for a moment because when we were doing the class yesterday, we noticed that there were a number of customers that had older systems. And if you have a system where you have a black box about the size and shape of one of your Sentinel faceplates that does not have a keypad, but it sits on your desk or near your desk and has a cable that runs to your computer, you have what is called a Central Interface Module, CIM. We like to come up with fancy names for all this stuff. Well, those are good, but we realized a number of years ago that we needed to separate the location of that base radio from the computer because we started getting into different types of sites and challenging sites where we needed to expand out the radio communication a bit. So we started to produce this piece of equipment called a CTM. Now the CTM is an acronym for another fancy name, Communication Termination Module. It is pretty much the same thing as a CIM with some advanced connections on it. I'm going to show you some here in just a moment with the camera I've got. I've got the board of a CTM to show you what it looks like on the inside. But essentially that CTM, it can be located next to your computer if you wanted it to and connect up via serial cable, or it can be in the top of in a mechanical room of a building where you connect to it through a network Ethernet cable or cell modem, and then from there go out radio. And I should say the CTM, the termination word, is really not true because the communication does not terminate in that box. What happens is that the communication into that CTM occurs through your software and more typically through a Ethernet cable network connection, gets into that box, into the CTM, and then it converts over to UHF radio, and then from there communicates out to the field. Now the lower three we see occasionally, not often. Wi-Fi, I have a few out there that are that way. 900 megahertz, special applications where we've got small sites, open sites. We may do a 900 megahertz from the computer out to the field, but it's rare. And even rarer is the last one, is phone modem. And with the phone modem, there are still a few out there that do dial up. Hopefully these all go away. It's hard to even get a landline in an office anymore. I mean, everybody's going to cell, and you can't find replacement cell modems. So I know sites that had phone modems, even competitive sites with competitive product, they're wanting to get off of that technology and go to something that's more advanced, and it's going into the cell data modem, which I'll be talking quite a bit about. But these are the three we're going to focus in on this afternoon in communication, because these really are the three most common forms of communication out to any Sentinel controller, where it's either going into a CTM, converting to radio, going cell modem, which we're doing more and more with cell, or it's direct line Ethernet right to the controller, which I'll show you on the version 3 how this works. In that design guide, this is one of the pages from it, as was the previous. This kind of gives you a little better explanation of what happens in the process of all this communication. If you go, I know it's kind of busy right there, but go to the middle of the page where you see your central computer. Everything originates at the central computer. So if you're initiating a command, say you're going to do you made a change to a program, and you want that program to get downloaded to the controller. You're making that change in your software. If you were on the earlier class this morning, we talked about how you saved it in your software, and then it's in your database, and then you hit the send. Well, depending on how you are connected to that CTM, and you see right there, it's showing serial cable, Ethernet, cell modem. Those are typical connections to these CTMs. The most typical one is normally over Ethernet, where it's going in on a university mechanical room somewhere in a building. It's going in a school district in a building. I have one that's located here in Richmond. It's on a Capital One bank campus. And contractors locally here take care of the site. Well, everything was passing through or is passing through a CTM there. The computer could not get on the internet at Capital One, which is typical. They're not going to let, something like that be on the network of a bank. So the contractor went out and purchased a cell modem and connected it to the CTM so that they could get access to it from off-site. Essentially, it's like Ethernet, but they're just going through a Verizon tower. So after it gets to the CTM, next thing it's going to do is convert your command to UHF radio. And depending on where you are, how big of an antenna you need, if it's on top of a building or whatever it may be, then it's going to transmit out to the controller, and then the controller gets the signal that you sent. Then what happens is the controller will transmit back. Now, this is not a radio troubleshooting class. You can certainly ask questions about it, but you have to understand that when you're transmitting UHF radio, and it's pretty robust signal. You're going to see some examples I'm going to show here in a moment. But radio signals change over time. Hardware changes over time. Antennas degrade. I've seen these base antennas that were mounted up on top of buildings, and they were exposed to all the elements of the sun for years, and then you go up there and all of a sudden the signal strength has diminished. And I know one of them in particular, the contractor went up there and the antenna material, fiberglass, had just gone brittle on it. The coax cable in the connections can start to degrade, especially if they were not put in watertight initially. And this is really where your distributor comes in and can provide assistance, because they have tons of experience in doing things with radio and using the right connections for everything. But also what you have to understand as well is that when you transmit radio signal to a controller, and you see the example is a stainless pedestal right there. Those stainless pedestals come with a what we refer to as a pancake antenna. It's a flat omnidirectional antenna that's secured to the lid. Now, that's only 3 feet up off the ground. If all of a sudden landscapers come in and plant shrubs around, the pedestal to hide it, they come in, build a new parking garage, whatever, things can change. So you need to understand that over time, radio from the day that it goes in is not going to be the same forever. And so with vegetation maturing, construction happening everywhere, from time to time there may need to be adjustments to radio. That's normal. That is normal. So I'm going to show you a couple of examples where CTMs were used. This is a building on the campus of University of Alabama in Tuscaloosa. And you can see the height of that building. This was near the stadium. At the time that University of Alabama converted to Sentinel, they had probably about 40 or 50 controllers that were existing on the campus, but it's a huge campus. I believe now there's over 40,000 students on that campus when all the students are back. And so, what we learned from experience by coming into some of these sites is that we can take advantage of height of existing structures. And so locating a mechanical room that had network access where an antenna could be mounted on top of the building was advantageous for us to get communication out across the campus. So the University of Alabama IT department said, hey, I believe this was a dormitory, said go to this building, We already use it for some sort of function similar to this, and here's where you need to locate your equipment. Well, when you look at the University of Alabama campus, and this campus has since grown not only geographically because they've added additional buildings, but it's grown with irrigation, with Sentinel irrigation controllers. They're now up to, Bruce, I believe you said yesterday, 80 or 90 maybe? No, maybe that was on Notre Dame, but I think
Notre Dame. Yeah.
I know Alabama is up over 80 on their campus. And they've since included, initially they did just the all of the campus buildings, but then they've also added all of the athletics on here as well. So you can see the stadium, the fields down to the lower center, all of that has been added in on the Sentinel right here. Now, kind of the unique thing, and they do the same thing at Notre Dame, which I've got a picture of right here. And this is the building that they broadcasted it off of Notre Dame. I know at one time they were sharing the same base radio right here. I don't know if they still do that at Notre Dame, Bruce, or not.
Athletics is separate now.
Okay,
Same building.
Base, but they're essentially running all Sentinel controllers, two separate systems. And the neat thing about that, the way they can do it, is that by changing frequencies in these UHF radios, it's kind of like saying you're on, your own separate Wi-Fi network right here. And that's what we do with this UHF. The whole benefit of doing this, and this is not just for university campuses, it works great here because we typically find a high concentration of controllers, but you're getting free communications. You're not paying reoccurring charges for data or anything like that. And when you have this many controllers that could be in one location and you can get to it with radio, it's certainly what we want to bring to the customer to see. But we've got all sorts of applications out there where school districts will take and they'll mount a CTM inside of a school building and then put a small antenna up on top of the building, broadcast out UHF radio just to the sports fields and pick up, good communication out to where obviously they can't get any cables, Ethernet cables or anything like that. So this is a very typical use of that CTM, not the only, but it's a very typical use of it. Back probably about 10 years ago, when we still had only that central interface module, that black box, we started realizing that we needed to separate that black box from the computer and not have it hooked up via serial cable. So we started using Ethernet modems. And I know one of the first places that I worked on that utilized this was at University of Minnesota up in Minneapolis. They have a very dense campus there in Minneapolis. And so we wanted to put this on the network. Well, that CIM, if you happen to have one and you look at the back of it, I don't have a photo of it or even one here to show you, but if you look at the back of it, you have a single serial port. And so what we have to do with these Ethernet modems, or what we did then, was we had to come in with a Cat5 connection. And so I'm going to get my laser pointer back here so I show you what I'm talking about. So you see right here is a Cat5 connection. That's your power on the left side of the Cat5. What we would end up doing is, again, going to the IT department, asking for an Ethernet connection with an IP address. We would run that Ethernet connection into this device, which is called a Blue Heat, comes from a company out of Canada called ConnectTech. And on the other side of it are two serial ports. We'll just call it port 1, port 2. They call it serial 1, serial 2, right here on this photo right here. We would then in turn take a serial cable, just like you have if you've got one of those central interface modules going into that black box. In essence, you have the same serial cable, but it comes out of this serial 1 connection and runs into the black box. Then from the black box, the CIM goes up to your UHF antenna and broadcast out radio. Worked fine, but it was a little clunky with the fact that you had to have this extra hardware and everything. I will say one nice thing about using this Blue Heat modem, the fact that it has serial 1 and serial 2, a number of customers took advantage of the fact that it had a second serial port. So when these things were programmed up, port 1 was defined as a port number, and I'm not going to get in the weeds of all this, but a number 10,001 would be associated to port 1. Port 2 would be defined with port 10,002. Same IP address coming in. Okay, so let's say the IP address was 192.168.42.10. And then if you wanted to talk to the black box radio, the extension would be :10,001. So whenever you communicated, it knew to communicate over port 1. If you wanted to go to a weather station, say a Davis weather station console, the back end of that IP address, 192.168.42.10, would have :10,002, and it would transmit over serial 2. So it allowed you to get double access to devices out of one piece of hardware and one IP address. So the IT department did not have to provide 2 Ethernet drops right there. We have also seen an enormous amount of cell data modems being used recently over the last few years. Reason for this, the prices have come down. Data charges have come down, and it's a very fast communication. Now, the modem that you see right here, and Toro does not manufacture cell data modem. Going back to the previous slide, we do manufacture our own Ethernet modem, but it only has a single serial port, and we still use them. We use them for places where they want to have remote connectivity to a weather station. We do not manufacture a cell data modem. This one is provided by a company called Sierra Wireless. There are numerous companies out and about in the United States and also in Canada that manufacture cell data modems. But let me just caution you, if you want to go towards a cell data modem, I would strongly recommend that you contact your Toro distributor, and through us, we will recommend one of our pre-approved vendors, because these have to be configured a certain way that makes it easier, almost a plug-and-play connectivity to your Sentinel controller or to your CTM. Let me get back to my laser pointer, and let me explain to you what you see on this device. So you've got antenna connections up here. You've got your power connection. You have Ethernet. Now the Ethernet is not incoming. It's outgoing Ethernet connection. So what ends up happening is the Ethernet, or the internet signal that's coming through, is coming through a cell tower. The cell providers in the United States, the predominant ones, are going to be Verizon, AT&T, T-Mobile, and Sprint are going to be the main providers of these cell signals and the cell towers to get your signal. Now, this also has a 9-pin serial adapter. I have had some customers that had controllers that were remotely located, and they came out there, they added this cell modem to it, plugged the Cat5 in from the cell modem into their version 3 controller, and I'm going to be showing you this in a moment. If you have, and I should stop here and explain this for just a second, if you have predominantly version 2 controllers, that means that your controller does not have a dial on it. It's just a keypad. When you boot it up, it either comes up to a 1 dot something or a 2 dot something on the firmware. You have to use an Ethernet modem in between the cell signal and the controller, unless your cell modem has a serial port on it. You have to use some sort of Ethernet modem to get into that. It does not have a Cat5 connection, the version 2. Version 3 controllers, you'll see in a moment, has its own built-in Cat5 connection. So we can take this cell modem, take a short piece of Cat5 cable, Ethernet cable, plug it in here, plug it into the top of the version 3 controller, and have instant communications. If we're going to dual purpose this, then you're going to take and plug a null modem cable into this port and go into the console of the weather station. And I've dual purposed these before, and they work very well. Also, this modem that you see right here is a 4G LTE modem. If you have older modems that are in place, if they're 3G, beware that that 3G will be disconnected at some point. Here in the United States, they've already started disconnecting them. I've got out of my garage probably 3 or 4 modems that were 3G that were deactivated because we took them offline for a period of time, and then I wanted to reuse them to go put into demo units. I went back to the cell provider and said, hey, I want to get a SIM card. I want to get this reactivated. They would not even reactivate it for, 6 months. They said, we're taking these offline. We're not reactivating anything new. So it needs to be 4G LTE on the modems today. To my knowledge, there are no 5G modems yet. I'm sure at some point that there will be 5G. I know one of the cell providers up in Canada is a company called Rogers. I don't know if that's also like in British Columbia and everything, if that's the same. I know in the Ontario, Toronto area, Rogers is a big carrier over there. Bruce, anything that we need to address yet?
Nope. So far,
okay.
So good.
All right. So I have this picture here from the design guide, that what I wanted to explain is a unique feature of the controller you may or may not be aware of. You notice the illustration at the bottom on the left side shows the same image I showed just before about an Ethernet cell modem serial going into the CTM. Well, then a lot of times you have a controller that might be at a location, and if it's at a park site, you might have direct Ethernet to that controller, or at the very least you could put a cell modem into it. Well, let's say that you have a park site and there's 4 controllers at that park site, and you don't want to go and put a cell modem into each of the controllers. You could if you wanted to, or Ethernet, try to get Ethernet to each one of the controllers. So instead, what you can do is find one of the controllers you're going to use as your main hub. And let's say we're going to do cell modem. I'm going to take that controller. It's going to be running irrigation. It could be, 12 stations. It could be a 2-wire station doing 204. It does not matter. But I'm going to designate that one controller as my hub. So I'm going to call that, I'm going to just say that we put an address of 001 on that controller. But I've got 002, 003, 004 also located at the same park site. I only want to use one cell modem. So what I'm going to do is I'm going to hook the cell modem up to 001. And when I go to communicate from my software, I'm going to take the IP address and I'm going to plug it into my software. And it knows that when I want to send or receive, it goes to unit 001. Well, what's pretty cool about this technology is, let's say that I want to talk to 002. Well, if I want to talk to 2, I'm going to use the same IP address that I just plugged in to the communication tab for 001. Exact same IP address, nothing different. So when I go to communicate to 2, 3, or 4, when it reaches unit 1, it realizes that it's not the controller that I am asking to talk to or to download a change to. So when it realizes that, what it ends up doing is immediately transitions to its UHF radio. And the UHF radio starts calling out to whatever vicinity, whatever range it has that it can signal to. and it starts saying, is there a unit 002 out there? And if 2 is within radio range of 001, 002 will respond back to 001 and transmit back through the cell data modem or Ethernet back to your computer. And so you can use that controller not only as an irrigation controller, but as a CTM down at the bottom. It's a dual functioning piece of hardware. The inside equipment is very similar, which I'll show you something here in a moment that on the boards with that. So if you've got anything like that that you're going to be adding on in the future, make sure that you take advantage. Now, I'm going to get into a little more detail of communication from the faceplate to the valves. And this is all version 3. And if you hadn't heard me on a previous session talk about this, if you still have version 1s and if you still have version 2s, we encourage you to contact your Toro distributor and find out about our version 2 to version 3 upgrade program. It's a very affordable way for you to get brand new equipment. You exchange, give us back your version 2 controller. We recycle parts that we still need out of the version 2. You get a brand new version 3 with all the new features, and you get a brand new 5-year warranty. So make sure that if you have any of these, that you're finding out what the cost is to get them all swapped out. It's worth it for the warranty to do this. And you're going to see we've got a lot of new cool features. I'm going to be talking about these starting on Monday. We've got so many new things that we're doing with this that you're going to probably want to take advantage. So let's look at the communication on this page. It's from the design guide. And we're going to look at the first picture right there, which is the old school conventional way of turning valves on from a faceplate. You've got your faceplate or TM, timing module, same thing, okay? That's the keypad with the dial on it. I want to start a station or have a program that's set to come on. And when it's time to turn that station on, an electrical signal transmits through a ribbon cable that's attached to the bottom of the faceplate. And it transmits a signal down to your board, which is mounted inside the cabinet, and it electrically activates and turns a switch so that station can come on. It's the way that irrigation has been done for years. It's the way every other irrigation manufacturer does their activation of valves. But then we came up with a fairly unique way of doing the same thing, but without those ribbon cables. This is called short-range wireless. And in this particular case, you've got a similar faceplate. It does not have any connections on the bottom, but it has a small short-range radio that is located inside that faceplate, inside the TM. And there is a second short-range radio that is located on the output port right there. So when it's time to turn a station on, whether it's manual or automatic, it doesn't matter. The TM transmits a signal down to the board. The board receives the signal and turns on this station. Think of you changing the channel on your remote on your TV. You type in channel, 800 or whatever it might be on cable, and then your TV jumps right to it. It's a similar technology to doing that. Well, why would we do this? There are some reasons. One is we've now made a physical separation between the output board and the faceplate. When you take a lightning hit, if you're in any lightning prone area, I know a number of you looking at where you were logging in from, you're in lightning areas. You take a lightning hit. What it's typically going to do is it's going to hit the ground. It's going to get into that copper wire, and it's going to go to the path of least resistance. Well, if it hits near your controller, chances are that power surge is going to transmit up your copper wire into the controller and into the output board. Well, the brains and really a lot of the expenses in that faceplate. It's not so much on the board. We have surge protection on the board, but having that gap, call it an air gap like a vacuum breaker or backflow device, it can't get up into that faceplate. The other neat thing about that is if you start to build a big inventory of these wireless controllers out there and you needed some backup controllers, you have one size fits all. If you look at item 1, that's a 48 station. It's got 4 connections on the bottom, 4 ribbon cables. I would have to keep a 48 station with 4 connections on it in order to run a 48 station board. And 2, you don't have that. It's a single faceplate. There are no connections on the bottom. It just has that radio. Then we get into option 3. On option 3, we're doing a similar communication. Now, and I should mention that the radio signal that we're transmitting in this wireless is what's called a spread spectrum. On item 3, we're communicating over what's called 900 megahertz is the frequency. On your UHF radio, you're communicating, unless you've got a government site, you're communicating between 450 and 470 megahertz. On this spread spectrum, we're communicating at 900 megahertz. So what do we use this for? This is a long-range wireless. And when we do a long-range wireless, you can have the faceplate talk to a board inside a cabinet, and then it can also go to a long-range radio that we plug up to one of the serial ports of the controller. And then out in the field, we can just put a wireless board with a wireless radio on the board. It has no faceplate. But when we do this, what it does is it actually expands the station count of that faceplate where it shows item 3 or that little letter E, that timing module. So if you look in that illustration, there's a 12-station board below it. There's a 48-station wireless board. The controller thinks it's a 60-station controller, and you can program all the way up to 204 through one of these V3 faceplates. So I could put additional wireless boards. Where would I use this? Normally this is used if you want to have multiple controllers out in the field sharing on the same water source. So whether you run your flow meter into the controller location with a faceplate or you run your flow meter into a wireless board, whatever it may be, we can expand the station count out in the field, especially when you get into areas you got loop mains and crazy things on irrigation. We see it every day. And then lastly is our 2-wire. We make a couple of versions of 2-wire, but our most popular 2-wire that we're selling today is the one that we use with our AC solenoids. You're going to see on Monday with the new features, we've added some new capabilities to it, which make it very attractive. If you're not using 2-wire and you think you may in the future, that's the controller that you want to use, that Sentinel AC 2-wire. Extremely robust product with both decoders and controller. Anything, Bruce, that I need to talk about at this point?
There was a quick question on the going back between version 2 and version 3, how the version 3, when you do handheld commands, it requires a 4th digit in your commands.
That correct. It requires a 4th digit. That can be changed in your software to be 3 digits. Okay, so I'll show you that here in just a moment, but I wanted to show a little bit about the controller first, okay? And actually, I think what I'll do is, before I get into the controller, show you a CTM board. So here is a CTM board, and hopefully everybody can see this pretty well. Bruce, you see it?
Yeah, very clear.
Okay, good. So let me show you. This is the guts of the CTM, not the CIM, not the black box, but that stainless steel box that people are using these days for remote communication. right here is where your incoming power would come in on our little green connection. Here's our here's our microchip, just like you have in a version 3 controller. There's our battery backup right here. Okay. Here's where our radio would connect. I don't have the radio connected to it, but this is where the UHF radio would connect to. Here are 2 serial ports, just like it is on a controller. We have 2 serial ports. And so if you wanted to, if you did have this mounted next to your controller, next to your computer, you could run a serial cable. And I've got a serial cable right here. I could take this serial cable and plug it into one of these ports right here and run it just like I would a CIM, a black box. I refer to it as the black box radio on it. But I want you to notice what's up here at the top, right here. That has a Cat5 connection to it. So in most cases, what people use the CTM for is they'll come in and they'll take a Cat5 network drop somewhere, say in a mechanical room, could be in a attic, could be wherever you have access to it, and run that Cat5 right into this connection right here. Now we're going over super fast communication to get to this. And then from there, it will convert to radio and go out radio to the field on it. So let's look at our V3 faceplate for a second. Now the V3 faceplate on the top has a similar radio connection. It has a serial port. This is where I would connect the cable to go to my flow meters right here. If I'm using soil moisture sensing and I'm using wireless soil moisture sensing, I would connect the wireless base station right here. When I look on the other side, I have a second serial port. I have my incoming power right here. So what I'm going to do now is I'm going to take a serial cable and I'm going to connect it up to the bottom port right here. Okay, so you see how I just connected it right there to that bottom serial port. If you've got controllers that are out in the field and you have no means of radio communication or Ethernet or anything like that, and you want to communicate to it, you can go out with your laptop, get a serial cable, connect up your serial cable to your controller, and do what I'm going to do right here. Okay? But I'm going to show you how you do this in order to communicate to it properly. First thing I'm going to do is I'm going to go check the unit code. So you notice I'm right here at satellite settings. I'm going to click on satellite settings, and I'm going to turn it to where it says unit code, and I'm going to hit enter. This unit is 452. If I wanted to change this to 451, I'm going to move over here to 451 and change it to 451. And you notice how that cursor is flashing. If I don't hit enter right here or push this dial in, it doesn't save that. If you were on the class this morning, I was talking about that. And it's like your prompt saving in the controller. So now I've created this as 451. So what I need to do next in the controller is check and see what this bottom port is set to. So I'm going to go to options. And when I go to options, I'm going to turn the dial to where I start saying port functions. When you see port 0, BK, that's the back port. I say the top port. And then port 1 says FT for front function. I'm going to hit enter, and I'm going to look at it, see what it's set to. If it's set on anything other than default, I can't communicate with my serial cable. Now, let's say you had a 2-wire controller. If you had a 2-wire controller, and I don't want to get off topic, but if you had a 2-wire controller and it's not set to 2-wire function here, whatever type it is, that's for the AC 2-wire. This is for the DC 2-wire. Then your signal is not going to transmit out of that serial port to the 2-wire port. Just FYI on that. But I'm set at default, so I'm just going to hit the back button, let it come back up to the home screen here for a moment. And I'm going to open up my software. And so when I look in my database of my software, I have 3 controllers created, 001, 002, 003. I need to add 451. So if you remember, if you were on the class earlier, in order to do that, we go to Manage. I'm going to click on Add New Unit to Database. And when I add this unit to my database, I'm going to put in 451. And I'm going to click OK. 451 appears here. 451 appears over here in my satellite panel. I'm going to close out of this. I don't need to add any more controllers. So now I'm going to click on and open up the menu for 451. First place I need to go to is satellite settings. When I open up satellite settings, used to be known as special data, a lot of the screens, a lot of the boxes, a lot of my options are grayed out here. They are grayed out because I do not know what my firmware version is of my controller. So I have to input some form of communication to this controller in order for it to talk to 451 and find out that firmware version to begin doing things. So I'm going to go to COM settings right here. And when I open up COM settings, there's all kinds of stuff I could put in here. And I want you to notice up here where it says profile. When you have it on unknown, essentially it opens up any of these boxes for me to use. COM settings, phone modems for those unfortunate people that still have to do dial-up. Field access URL if you're doing IP. This is some new stuff that's going to be coming in the pipeline later. But if I were to come in here and go serial direct radio, you notice how it grays out all this other stuff. It only allows me to do COM setting, COM port settings right here. I don't have to have it set to that profile in order for it to communicate on that. So I'm going to put it back on unknown. And I've already gone in and I'm using a USB to 9-pin adapter. Let me show you quickly. Let me go back. I'm going to minimize this for just a second. Okay, you see my connection right here where it kind of goes to this shiny silver cable. Well, on the other end of that shiny silver cable is a USB connection. And that plugs into my serial port. Normally, when you put these onto your computers, because when you go to get a computer these days, you're not going to find a computer unless you get a desktop workstation. You're not going to find a computer with the serial port. If you're using a laptop, it's not going to come with the serial port. You're going to get USB if you're lucky. And now they're doing USB-C, which is a smaller connection. On the USB-C, what you have to do is get a USB to C to standard USB connection. And you can get those on Amazon or you can get them at an office store. I already know that when I loaded this up, it came in as COM port 6. So we give you 4 radio buttons here that if it fell into 2, 3, or 4, I could check this right here and set it, but it's not. I'm going above COM4 because when I plugged in my USB to 9-pin, it assigned it to COM6. Now, the way I found that out is I went into what's called Device Manager on my computer. You may or may not be able to do that based on your IT lockdown of your computer. I was able to go in and see that I was on COM 6. So I am changing my active COM port to COM 6. And I'm going to save that. Okay? And I've saved it, just like I just saved that unit code on that controller. Now, I have one more step to do here. There is a box that is down here that if it's any version 3 device that I am communicating to, be it a CTM or directly to a version 3 controller via cell modem or Ethernet, I have to have packet COM checked. If you're going through the old black box radio, you do not check packet COM right here. If you're going through a cell modem to a version 2 or an Ethernet modem to a version 2, you do not check packet COM. It is only with version 3. It has to be checked. So I made that change. I'm going to hit save. I'm going to come back over to the tab that says General. I want to get this firmware version right here. So you notice how it's got its own receive button. I'm going to use that receive button now and check it. And it did not communicate. And I changed my USB connection today. And let me check here real quick in Device Manager. So let's take a look here and see what it shows. So I'm going to open up my Device Manager here. And I'm looking on my other screen, and it changed it to COM 7. So let me bring this over, see if I can drag this over for you to see. So this is what it looks like when I opened up Device Manager. I typed Device Manager in my search right here. It brought it up. I opened it, and I came down here to ports, and you see how I plugged into a different port today. I was moving my wires around. So it changed it to 7, which is good. So instead of me just taking shots in the dark, I just changed that to 7. I'll save it again, leave packet COM checked. Let's go try this again. And there, it communicated. So it brought my firmware version in for me. And when it did, it unlocked all sorts of features that were previously locked in. Now, from this point forward, now that I've communicated to it, I can communicate from any screen. You see? I can open up, and if I wanted to synchronize time and day, I can synchronize time and day. You see? So I have full control of my controller right here. Now, one other handy little thing, if you're out at a site where you've got multiple controllers, if you happen to be doing this in the field, and say there was another controller, but you didn't want to walk over to it, and you wanted to do the same thing, say I had a 452 out there. When I go into 452, all I'm doing is putting it on COM 7, and I'm going to still be connected to 451, just like I showed that kind of repeater effect. I can stay connected to 451, and it'll go radio over to 452 as long as I set it up as COM 7. It's going to go into COM 1, go into unit 451, realize that's not the one I want to talk to, and it's going to transmit a radio signal to 452, which is kind of cool right there. Are there any questions, Bruce, that anybody has on this?
Nope, there haven't been any questions. Jim, can you go back to the General tab?
Yes.
One thing that if where you get down to our station count, whenever you're doing UHF radio, you want to keep that to the minimum number possible, because otherwise, if you have a lot of controllers, all you're doing is sending data that is not relevant. Can you expound on that?
Absolutely. I have seen people, Bruce, where I've gone out there, they've had the controller wired up to 24 valves, and they've had it set to 204. And essentially, you're receiving 180 valve, more valve information than you actually have. It's a waste of radio signal. So do what Bruce said. Whatever your station count is, maxes out, set it right here, save it, and download it to the controller, which I'll do right now. So I'll make that controller a 24 station. The other thing you can do, if you wanted to, is I could come in here, and if say I'm not connected yet and I want to do some programming to my controller, remember how all this was grayed out? If you double click on that firmware version, and I'm going to show you, I'm going to put it back to a 247 right there, and I'm going to save it. Then I'm going to hit refresh and watch what happens on that screen. This is what you get available to you if you're running a version 2 controller. Not a lot. Not a lot. So if I'm running version 3, which I am, it unlocks all that. To the question about the version 3, version 2, you see this little box right here. If you check handheld remote V2 compatibility mode and save it and send it, it will take your 4-digit unit code, which would have been 0451, and changes it back to just 451 when you do your handheld. So, but you've got to check that, and you've got to send it. You have to do it from the software right there. So I'm going to do a setup on an IP controller. So I'm going to add another unit in. So this one I'm going to come in, and I'm going to create a unit 7, 007. And I'll go ahead right here, and I'll say IP controller. Now, whether this is going through a CTM, cell modem, direct Ethernet, whatever it is, this is what you would typically do. So now I've got 007. I labeled it as IP controller. I'm going to open it up. I'm going to go to comm settings again. Okay, I need to go here. I'm going to leave it on unknown. If I wanted to, I could go IP. You see what it does? It grayed out all my serial connections. So then I'm going to come down to field access URL, and I'm going to type in the IP address that was provided to me. Okay. Now I've got the IP address provided, but I've got to do a couple of more minor things here. I'm going to put a colon, dot, right there, not semicolon, but colon. And I'm going to put another number, a number 1000. What that number 1000 represents is the outbound port of the Ethernet device that I'm going through. So if I'm using a cell data modem, I need to make sure that port 1000 is not blocked. That's why when we said earlier, if you're interested in going cell or using cell, get with your distributor, me, Bruce, and we will send you a recommendation of a vendor that we have worked with that pre-configures these. So port 1000 is not a blocked port. I need to also check packet comm right here, and I will save it just like I did before. I'm going to flip back over to the general tab, but before I do this, I should show you on some devices, and that would be here on a CTM. It would be if I'm doing direct Ethernet to a controller, not if you're using cell. Typically cell requires a little bit different setup, but you may need to come in to your controller and come here and input the incoming IP address. So if you're working with your IT department,
Hey, John, can I call you back?
or if it comes with the cell modem and the cell provider says, put this IP address in, you're going to need to navigate down and input in that IP address, because otherwise it's kind of like a phone number trying to dial up a phone, and the phone can't respond because it has not been assigned that IP address. So be aware that if you're doing that on a CTM or a controller, especially when you're going direct Ethernet, that is a requirement. So I'm going to come back here. This one's already been set up in the field. I'm going to receive the firmware, and it happens so fast. If you look in the bottom left corner, it said alarm indicated. And if you see where my info panel is, I have it minimized. If I wanted to expand it, I could expand it there. I like to just keep it minimized. That communication over 4G LTE Verizon service took and this is a 0.488 seconds to communicate. And so I brought in the firmware version right here. So let's receive the data. So now I'm going to receive everything here. This is set up as a 48 station controller on it. Let me see if there's anything set up. There's something set up on a flow meter. You see it as a K and an offset. So I'm remoting into this controller via cell. I can do anything I want. Now, the only difference is if I were doing this through a CTM, would be that I would connect to it via either the cell or the Ethernet, and it would take a little bit longer because it now has to transmit a radio UHF signal to the other controller. But that first step of communication is going to be rocket fast. The second part is going to be just a little bit slower coming in right there. So hopefully this illustrated to you some of the basics of communication right here and what's involved. Are there any questions, Bruce?
Yeah, Jim,
I can cover right here.
there was one. If you can go back to your general screen under satellite settings.
Okay. Does it matter which one? 7 or 4? Okay.
No, either one. And so it's the daily default, and then it's by month. The ET values.
Yes.
I know that's not a communication question, but somebody was wondering what that meant.
Sure. We're going to be doing a weather station class, which I'm going to be sending the schedule out later, and I'm going to be going into the micro details of this. But essentially, when you get into the version 3 controllers, and I can't remember which version it was, probably 3.2.1 and above, we gave you the ability to put a default ET on a monthly basis. So in essence, you could kind of do this on historical ET. So if you begin irrigating, say in April, I could say that this ET for the month of April is going to have a daily value. So yeah, default daily of 0.10. You see where it says default daily ET values by month. And then May, I could go in here and say that's 0.18. And then June, I could say that's 0.22. And then July, I could say that's 0.28. And so even if I didn't have a weather station, I could run it off ET. It's not as accurate, obviously, as having your own weather station. But it's better than just taking a, wild guess and saying, I need to run this long, and let me run it that way. This is somewhat of just running on historical ET. And you can do that. So therefore, whenever it ran on that daily basis, it would use that daily ET I plugged into that box as the amount to calculate based on, what time of the year it was. You still have to input precip rates, plant factors, all that. But from June to July, the run times automatically bump up because I'm now using a higher default daily ET.
All right, Jim, could you show them 2 more tricks? One is we have a Sentinel user that they said that when you have a web interface, or when you have an Ethernet connection, you can use the shortcut web interface. And I don't think we have time for that.
Yeah, I'll show that right now. Give me a second to do that. And I'm going to drag over my Google Chrome page. So I opened up just a web browser. And I'm going to type in IP address. And I've got a username and password that I had already previously saved. And I get this. This opens up whenever you have Ethernet connection or cell modem direct connected to a controller. You have access to this. This is not an app, but it's called a web interface. And in this case, we call it a web control panel. You can do a shortcut on your phone where you saved it, and all you have to do is just click on that shortcut and it'll take you right there. But what's really cool about this is if I click on where it says manual control of stations, I could come over here on station 8 and say I wanted to run that for, 15 minutes. I could hit not 3:15, but 15 minutes. And if I hit apply changes, I'm now turning on station 8 for 15 minutes right here. And this goes all the way up to 204. So it shows it in blocks. I have access to my programs. This is still labeled the old stuff right here. But I have access to my programs. I have access to put in rain days if I wanted to, change the percent scale. So I could say program 1, I want to put that in an 8-day rain hold and hit apply changes. And that would do it on program 1. If I wanted to do it across everything, I could do it right here. So when you have a cell modem or you have direct Ethernet, you have access to that. Is there another question too, Bruce?
Well, there was another question that I wanted to show them as far as using confirming UHF communication from satellite to satellite.
Okay. Let me go to another database real quick.
Well, and what I was referring to, Jim, was on the faceplate of the controller when you go to the option button.
Whoa. Okay. You mean the radio test?
Yeah.
Okay, perfect. Thank you. So what Bruce is mentioning, which is a really cool function of the Sentinel controller, is that if you have, say you even had a CTM already located up on a building somewhere with the tower, a radio antenna, or you put a new unit in and you want to test the radio, what you can do is come over to options. Now, if you put in a CTM, the CTM default unit code is 999. But if I have another one that's located somewhere nearby, say it's unit 600 right here. I enter that as the unit number that I want to bounce my signal off of. If this was a CTM and it's up on top of a building, I would have entered code 999. And then take my controller out to the location, approximate location where I want to locate it. I can test the radio signal. So then after I enter that in and save it, I'm going to go into diagnostics and alarms. And I'm going to turn my dial until I see UHF radio test. And as soon as I push this button, it's going to start a radio test, and it's going to show me whether I'm communicating or not. And you can see right here, I have no radio connected to it. So guess what my success percentage will be? 0 on this. But I believe it tries 5 times or something like that.
Yes.
And lets me know whether it communicated or not. So I stopped the communication after 2. But it would essentially transmit out of the radio on this controller to another controller that's locally installed, or it could be a CTM you have up on top of a building. Doesn't matter. Doesn't matter. Now, I should tell you that CTM, this gets a Unicode that has a Unicode just like a controller. You notice right there in that corner, right here, it says 999. That's the default Unicode it comes with on here. One of the black box radios, CIM, does not have a Unicode. You cannot program it and bounce a radio signal off of it. So that's one of the big differences there. Bruce, was there anything else?
There was also a question with regard to the web interface. Does that work with, I know it works with Android, does it work with Apple phones?
Yes, it doesn't matter. Yeah, I have an Apple phone and I use it all the time on my Apple. It's not operating system dependent.
Okay.